Okay, picture this. It's morning, you step into the shower, turn on the water, and it's just ice cold. Ugh.
Oh yeah, the worst wake-up call, where you're like halfway through a sink full of greasy dishes.
Exactly. And suddenly it's freezing. That lack of hot water just throws your whole day off, doesn't it?
Mm,
And you look at that big metal tank and just feel helpless, kind of.
totally, like it's some big mystery box.
Well, today we're cracking open that box, specifically the Bradford White MI5036FBN gas water heater. It's not just, plumbing hardware. For a lot of homes, it's the reliable heart of daily comfort.
Hmm.
And we're basing this deep dive on a really thorough guide that lays out all the key parts, the common headaches you might run into, and crucially, how to fix them.
And that's really our mission here, isn't it? To take you from feeling overwhelmed when an appliance acts up to feeling informed, maybe even confident.
Right.
Because honestly, understanding just a bit about how this thing works can save you so much hassle, maybe some money too. It just puts you back in control.
So, okay, this Bradford White model, the MI56FBN, it's got this reputation for being a real workhorse, right?
Mhm.
Reliable, efficient. What's behind that?
Yeah, it really does. It's known for heating water efficiently,
Yeah.
and it just, well, lasts. They've built it to be pretty robust. That's why you see it installed so often.
Okay.
And understanding why it's reliable or how to fix it when it's not starts with knowing the basic pieces, the anatomy, if you will.
All right, let's get into that anatomy then. Let's unpack this thing. Where do we even start? What are the really crucial bits inside the MI56FBN?
Okay, first up, and this is huge for safety, is the thermocouple.
The thermocouple.
Yeah.
Is that the little wire thingy you sometimes see right near the pilot light flame? Why is it so critical?
That's usually it, yeah. It's actually pretty clever. It's a thermoelectric device.
Mm.
Basically, the heat from the pilot flame makes it generate a tiny bit of electricity.
Okay.
And that tiny electric current is just enough to hold the gas valve open. So if the pilot light blows out, it cools down fast, the electricity stops.
And the gas valve snaps shut.
Exactly,
Yeah.
automatically. It's a brilliant, simple safety feature, prevents gas from just pouring out if the pilot's out.
Wow, okay. So it's like a constant little safety guard. That makes sense. Which leads us straight to the pilot light itself then.
Right. The pilot light is just that small, continuous flame. It's always there, ready to ignite the main gas burner whenever the thermostat says, hey, we need more hot water. It's the starter.
Gotcha. Now, the anode rod. I read about this in the guide, and honestly, I was surprised. It sounds way more important than you'd think. Kind of an unsung hero.
Oh, absolutely. You nailed it. Think about it. Your tank is steel, sitting there full of water, which has minerals, oxygen, things that cause rust and corrosion.
Right.
The anode rod is usually made of magnesium or aluminum, materials that corrode easier than the steel tank lining. So it basically attracts all that corrosive action to itself.
So it sacrifices itself.
Precisely.
Yeah.
It dissolves over time, gets eaten away, so your expensive tank doesn't. It's literally protecting the tank from rusting through and leaking. Checking and replacing this rod periodically,
Mhm.
probably the best bang for your buck maintenance you can do. Seriously.
That's actually amazing. Okay, sticking with safety, the temperature and pressure relief valve. The TMP valve. This sounds pretty darn important too.
It is non-negotiable important, your ultimate safety backup. See, when water heats up, it expands. In a sealed tank, that builds pressure.
Makes sense.
If the pressure gets too high, say over 150 psi, or the water gets dangerously hot, like above 210 Fahrenheit, this valve is designed to just pop open. It vents steam and water, relieving the pressure,
Preventing.
preventing the tank from rupturing, basically stopping it from turning into a bomb in your utility room. You do not mess with a TMP valve.
Okay, duly noted. Then we've got the gas burner itself. That's the main engine, right?
That's where the actual heating happens, yeah. It takes the gas from the valve, mixes it with air, and creates the flame that heats the bottom of the tank, transferring heat to the water inside. Pretty straightforward, but obviously essential.
And the hose connectors. Seems simple, but vital for getting water in and out.
Yep, got to connect it to your house's plumbing somehow.
Mm.
They need to be secure, no leaks.
Mm.
Basic, but fundamental.
And even the simpler things, like the cover, the access panel door gasket, they matter too.
They do. The cover protects all those internal parts from dust, dampness, maybe getting bumped, and that door gasket. It needs to seal properly. You don't want debris getting in or potentially combustion gases getting out. So yeah, even the simple stuff has a role.
Okay, then there's the dip tube. This one seemed a bit weird to me at first. Why send the cold water way down to the bottom?
Ah, clever physics.
Uh-huh.
Hot water naturally rises, right?
Right.
So the dip tube sends the incoming cold water straight to the bottom of the tank. This forces the hottest water, which is already up at the top, out through the hot water outlet pipe first.
Oh, so it keeps the hot and cold from mixing too much right away.
Exactly. It promotes stratification, makes the heating more efficient, and gives you hotter water for longer. Smart design.
Very clever. And lastly, the gas valve assembly, the main controller for the fuel.
Yep. It works with the thermostat. When the thermostat says need heat, the gas valve assembly opens to let the right amount of gas flow to the burner. When the temperature is right, it shuts off the flow to the main burner, leaving just the pilot, usually. It regulates everything.
Okay, wow. So seeing all those parts and how they work together, you can see why these things are generally reliable. But, like you said, nothing's perfect. Things go wrong. What are the usual suspects when the MI5036FBN starts acting up?
Yeah, even the best eventually need some attention. A really common one is the pilot light going out or flickering constantly.
Okay, what's usually behind that?
Often it's that thermocouple again. Either it's gotten dirty, soot buildup, or it's just worn out or damaged.
Yeah.
The fix. Try cleaning it carefully first. If that doesn't work, it likely needs replacing.
And the big one, just absolutely no hot water. Panic stations.
Right. That could still be the pilot light being completely out, maybe because of the thermocouple. Or it could be a problem with the gas valve assembly itself. Maybe it's not opening to let gas to the burner. Those often need a professional look.
Then there are leaks. Nobody wants to see water pooling around their water heater.
Definitely not. A leak could be something simple, like a loose connection at the hose connectors. Or it could be the T&P valve dripping, maybe doing its job, or maybe it's faulty.
Or the worst case.
Or, yeah, the worst case is the tank itself is leaking, probably because the anode rod was gone and the tank corroded through. First step always is find exactly where the water's coming from. Makes all the difference in the repair needed.
What about weird noises? That rumbling or popping sound people sometimes hear sounds alarming.
It does sound bad, yeah. But it's usually sediment. Minerals from the water settle at the bottom of the tank over time. That layer gets heated, traps water underneath, which boils and pops, making that rumbling sound.
Oh, so it's like mineral buildup causing mini explosions.
Kind of, yeah. The fix is usually flushing the tank, draining it out to get rid of that sediment layer. The guide usually explains how.
And fluctuating temperatures, like
Yeah.
scalding one minute, lukewarm the next.
Frustrating, right? That often points to a faulty thermostat. It's not reading the temperature correctly or telling the burner what to do properly. Or it could be that dip tube we talked about. If it's broken or cracked near the top, it might be dumping cold water right into the hot water outlet.
Ah, short-circuiting the system.
Exactly. Replacing the thermostat or the dip tube usually sorts that out.
Okay, so let's say you've figured it out. You need a new thermocouple or maybe that dip tube. Finding the exact right part can feel like searching for a needle in a haystack sometimes. How does the guide help with that?
That's a key step for sure. The guide suggests some good strategies. Filtering online parts suppliers by category like gas components or valves helps narrow it down. But the absolute most important thing, have your water heater's full model number, that MI5036FBN, ready. And if you can find the part number itself, maybe from the owner's manual or by looking at the old part, that's golden.
Use the diagrams in the manual.
Oh yeah, those exploded diagrams are fantastic. They show you exactly how everything fits together and often list the part numbers.
Yep.
And, for visual learners, the guide points out checking for repair videos online. Seeing someone replace that exact part can be super helpful.
Good tips. And what if you're just stuck? You've tried troubleshooting, you're looking for parts, but you're just not sure.
Well, the guide reminds us not to forget the manufacturer's support.
Yeah.
Bradford White actually has a 247 hotline. That's 1-800-269-2609.
Yeah.
And they apparently have live chat on their website too, so expert help is there if you hit a wall.
That's really good to know. Take some pressure off.
For sure. So when you boil it all down, knowing a bit about your water heater, its parts, what the common hiccups are, it really does empower you.
Yeah.
You can troubleshoot those common things, maybe even fix them yourself, or at least know what you're talking about if you do need to call a pro. It demystifies it, keeps the hot water flowing.
And I think that's the big takeaway, right? You go from that initial, oh no, moment when the shower runs cold to feeling like, okay, I have an idea what might be wrong here and I know where to start.
Exactly.
It really makes you think, doesn't it? How many other things in our homes seem like complex black boxes, but maybe, just maybe, they're understandable with a little bit of insight? Gives you a whole different perspective on keeping your home running smoothly.